Welcome back to the Sparkfun Inventors Kit for LabVIEW tutorial series. I'm Sam Kristoff from LabVIEW MakerHub, and in this section, we'll learn how to control a servo. I've connected the signal pin of my servo to pin 3 on the red board, and I've connected 5 volts and ground to the other 2 pins. In LabVIEW, I'll click Help and choose Find Examples. Then I'll click the Search tab and search for links. I'll open the Links Servo 1 channel example by double-clicking on it. In the serial port section, I'll select COM3, which is my red board, and I'll change the servo channel to pin 3. Then I'll run the VI. You'll notice there's a dial indicator, which ranges from 500 microseconds to 2500 microseconds. The way we control the servo angle is by sending it a pulse, and the width of the pulse determines the angle that the servo goes to. So in this case, as I rotate the dial, I can change the angle of the servo. And you'll notice that if I go too far one way, the servo starts twitching. That's because different servos have different minimum and maximum values. You'll want to find the minimum and maximum values for your servo to make sure you don't damage it. Let's see how this code works. I'll click the Stop button and press Ctrl E to bring up the block diagram. You can see we start by initializing a connection to the red board. Then we initialize one servo channel by passing it the channel number we want to open the servo on. Inside the loop, we call the servo one channel right to write the position of the servo. Outside the loop, when we're done with the servo channel, we close it, and then we close our connection to the red board and handle any errors. Let's say we want to update this code to create a windshield wiper effect. I'll expand my while loop, and we'll need to save 2 values. The first will be a Boolean. It'll represent whether we're counting up or down. The next will be the actual angle of the servo. So I'll right-click on the edge of the while loop and choose Add Shift Register, and I'll do the same again to add a second. We'll start with a true constant, and I'll use Quick Drop to place that by pressing Control Space. This will indicate that we're counting up to start. The other shift register will store our angle. So we'll use a numeric constant. And if we look, the servo position is at U16. So I'll right-click and choose Representation and choose U16 for our numeric constant. I'll wire that into the shift register, but we don't want a value of 0 here. We want our servo to start in a safe range. So we'll start it at 1000, and we'll have the servo move between 1000 and 2000 microseconds. Now we have 2 different cases we need to handle, counting up and counting down. So I'll use Quick Drop to place a case structure. I'll move the case selector up and wire in our count direction, which is a Boolean. The true case means we're counting up. I'll use Quick Drop to place an add primitive, and we'll add a value to our current count. I'll right-click on the bottom terminal and create a constant. And let's add 5 when we're counting up. I'll pass this value out and wire it into the shift register. And I'll also delete the servo position because we're no longer using that to control the servo. We're using the output of this case structure. And I'll wire that into the pulse width input of the servo right VI. Now, in the true case, we also need to determine if we've reached the maximum and need to switch directions. Switching directions in this case means changing the Boolean to false. So we'll continue outputting true while our value is less than 2000. So I'll place a less primitive. And we want to check if our current value is less than our maximum, 2000. We'll pass that out and pass it into the Boolean shift register. Now we need to do the same thing for our false case. This time I'll create a subtract primitive, and we'll take our current value minus some amount. I'll right-click on the bottom terminal and create a constant, and let's choose 20 this time so it returns faster. I'll I'll pass that value out, and now we need to check it. Our Boolean will remain false until our value is less than or equal to 1,000. So we'll say less or equal, and create a constant, and 1,000, and we'll pass out that Boolean value. So once we start counting down, we'll subtract 20 from our current position each iteration until our value is less than or equal to 1,000. In that case, our Boolean changes to true, and we'll start counting up. Let's return to the front panel and run the VI. Once LabVIEW establishes a connection to the breadboard, we should see the servo sweep back and forth. And notice how it goes faster in one direction than the other. That's because we used 5 when we're incrementing and 20 when we're decrementing. Think of ways you could use a servo in your next project. Could you use it with a potentiometer and have the potentiometer rotation control the servo rotation? Maybe you could create a physical temperature gauge where the servo is used to rotate a needle in front of a gauge drawing. Make sure to join us for the next section where we'll learn about detecting sound. Make sure to check out LabViewMakerHub.com for more tutorials and projects, and ask any questions you have on the MakerHub forums at LabViewMakerHub.com/forums.